Good day. Today we're looking at difference of perfect squares. The key word in this is difference. This only works for subtracting perfect squares. Now, to give you a warm-up into this, we're going to be foiling these sets of expressions. Now, by FOIL, what I mean is first times the first times the outer number, the inner two numbers, times the last two numbers. First, outer, inner, last, FOIL. Okay, for this one, I have x times x for x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. Negative 4 times positive 4 is negative 16. The negative 4 and positive 4 cancel. I have x squared minus 16. Okay, for the next one, I'm not going to draw this every time. You can see it. I hope you draw it, if it helps you. 5 times 5 is 25. M times m is m squared. 5 times negative 1 is negative 5m. 1 times positive 5 is positive 5m. 1 times negative 1 is negative 1. I'm left with 25m squared minus 1. All right, the last one is 4a squared negative 6ab positive 6ab negative 9a squared b squared. Whenever I simplify this, I have 4a squared minus 9a squared b squared. Not ab, just b squared. I apologize. I was writing too fast and not paying attention. There we go, that's better. These numbers on the right is what we do call a difference of squares. Both the first and second term are perfect squares, so you can take the square root of them, and you have a subtraction sign in between. These are very easy to factor because you can use Desmos. So this is a squared minus b squared becomes parenthesis a plus b value times a minus b value. That's all there is to it today. Number 1. The square root of a squared is a, so that's quantity a squared. The square root of 4 is 2, quantity 2 squared. Now my formula, the first one plus the second one, the first one minus the second one. Completely finished, I can do nothing else. Let's look at number 3. 81 minus x squared. All right, the square root of 81 is 9. The square root of x squared is x. 9 plus x, 9 minus x. Moving along to number 5, I have k squared plus 25. There should be an immediate red flag. This is a plus sign, not subtraction. This is not a difference. 5 is prime. Let's go down to number 11. 4h squared minus 25g squared. The square root of 4h squared will be 2h. Square root of 25g squared will be 5g. 2h plus 5g, 2h minus 5g, and parentheses. Done. Square root of both of these will be xy squared minus 1 squared. I wanted to show you this one because I had two variables in that first term. Okay, all those are good. So I want you to pause the video and try 1 through 12. Pause it again and try 13 through 20. Now let's go ahead and check our work for those. There's 1 through 12. 13 through 20. You have to be able to understand this part in order to do factoring with a GCF. You see, anytime that we factor any problem, you need to look for a GCF first. So let's go to number 23. I have 32s squared minus 18u squared. Now you can use Desmos to find the GCF, or you can look at this and know that it's 2. I don't care which way you do it. But I'm going to pull out a GCF of 2. And I'm going to be left with 16, and the variables are different, so I can't pull out a variable. But I'll be left with 16s squared minus 9u squared. Now I'm going to take the square root of both. So this will be 2 times square root of 16 is 4s minus square root of 9 is 3u squared. Now I'm using the formula, just leaving the 2 out front. 4s minus 3u, 4s plus 3u. Finished. Let's look at one more, and I'll let you try the rest. Actually, we'll look at 2 more. I want to look at number 29, and then number, not 29, 27, and then number 32. All right, number 27, 80 into the 4th minus 125 n squared. You can use Desmos to find the GCF between these two numbers. It is going to be 5 for the coefficients. I'm looking at my n terms. I have an n in both terms. The lowest exponent is 2. There's my GCF. I am left with 16 n squared minus 25 and no n's because I pulled both of them out. Five n squared. Square root of 16 is 4. The square root of 25 is 5. I'm just dropping the 5n squared down every time. 4n plus 5. 4n minus 5. And we're finished with that one. Now, number 32, I wanted to show you because I have no constant term, or no coefficients. So, m cubed n minus mn. I have an m in both terms, and I have an n in both terms. The lowest power of m is 1. The lowest power of n is also 1. I had 3 m's, I pulled out 1. I have m squared remaining. I had 1 n, I pulled it out. There's no n remaining. I'm pulling out both the m and the n. The invisible coefficient, -1, is remaining, or mn divided by mn is 1. Either way you want to look at that, I really don't care which way you want to do it. Now this is perfect squares. So mn times m plus 1, m minus 1. And we are done for this lesson. Try numbers 21 through 30, and then 31. I'll show you the answers, and you'll be done. There's your answers. I hope you have a great rest of your day.